Hello everyone and welcome. The focus of our lesson today is binary subtraction. I have broken this down into two key steps. The first step is you convert the number to be subtracted to its 2's complement form. We don't use sign and magnitude, we always make use of 2's complement form when we're performing arithmetic operations with binary. And then in the second step, you add the result from the step 1 here to the other number. Now one thing I would like you to remember here is that if for example we have x minus y to give us z, I want you to remember that this is the same as saying x plus minus y equals z. Just remember that. So let's take our first example. In our first example, we will subtract. Let's subtract 13 from 7. Okay, so technically speaking, we're saying here, 13 from 17. We're saying here 17 minus 13. 17 minus 13. The first thing you want to do is to represent these two values into their binary form. For this one, representing this to its 2's complement binary form is the same as representing it directly to its denary form. And we know that 17 in binary is 0, 0, 0, 1, 0, 0, 0, 1. Okay, if you don't know how to do this, you can check the other videos I've done on how to convert binary, denary to binary and binary back to denary. Now, for minus 13, we will need to represent. So we see in step 1 we said convert the number to be subtracted. So this number minus 13 would have to represent it in its 2's complement form. To do that, I would need to convert minus 13 now to its 2's complement form. First, I will represent 13 to binary. And 13 in binary is 0, 0, 0, 0. 1, 1, 0, 1. Okay, to convert it to its 2's complement form, first I'll convert it to its 1's complement form, which is flipping the 0's to 1's and the 1's to 0's. That's 1, 1, 1, 1, 0, 0, 1, 0. And then to its 2's complement form, I'll just add 1. And if I add 1 to that, I'll get 1, so that's 1 plus 0 giving me 1, and every other thing down here I'll just pull down because there's nothing else to add to them. So this value here represents minus 13 in its 2's complement form. And remember, like we said here, we have x, which is 17 here, plus, so we'll need to add this to minus 13 minus y minus 13. So I'll get my 17, and I know 17, so technically what I'm about to do here is I'm about to say 17 plus minus 13. So we know that 17 is not 1, not 1, and we know that minus 13 is 1, 1, 1, 1, not 1, 1. And all I have to do now is add both numbers together. And if I add the two numbers together, I would have 1 plus 1, which is 0 carry 1. 1 plus 1 is 0 carry 1. and I'll put that 1 there. So 0 plus 0 plus 1 is 1. 0 plus 0 is 0. 1 plus 1 is 0, carry 1. 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 Now I'm going to stop here. Some students get confused at this point on why this value isn't treated as an overflow and then we put the 1 there. No, it's not. Remember that when we did minus 13 here, we had not 1 1 not 1. This is exactly the same thing. If I add multiple zeros in front here, it won't affect my value for minus 13, which therefore means that if I had flipped these multiple zeros, I would have a recurring 1. So with negative values, we have multiple recurring 1s in front there, which means technically that if I keep adding my carry here, I would have 1s to be adding my carry to, which means I'll have multiple zeros there. That's why we stop here. Okay, and this plays a key role when we start normalizing numbers, but we'll look at normalization in a future lesson. Okay, so we know that 17 minus 13 will give us 4, and if we convert this value here, 1, 2, 4, we know the answer is 4.